and then we use them to find this like total volume of this composite figure. And we do that by either adding or subtracting. Okay, so we're always combining, and combine could mean add or subtract. So let's look at our examples. Example 1, right? We have this towery looking thing. So the first thing we always want to do is determine which shapes are in this shape. So, increase the thickness here, right? If we look here, the first shape I see is this cone. Okay, so we have a cone here. The other shape I see right, is this cylinder that's like underneath the cone. Okay, so these are our two shapes that we have. We have a cone and a cylinder. So what we're going to do again is we're going to find the volume of these two shapes completely separately. We're going to think that they have nothing to do with each other. So our cone, first we're going to write down our volume formula. The volume of a cone is volume equals 1/3 pi r squared times height. And again, we can kind of think, is it OneNote doing it or my board doing it? Remembering these formulas, right? The easiest way again is this cone has a circle bottom and a point on top. So since it has a point, that's where the 1/3 comes from. And since it's a circle, that's where the pi r squared comes from. And there's always a height. So now I have 1/3 and pi. And then my radius, right? Again, radius is half the distance across your circle. That's supposed to be a... the distance across our circle. So I don't have to do anything with it, right? Remember, radius is the definition of radius is half the distance. So since this line only goes halfway, I just get to use this 3 that's already there as my radius. And then our height is 4. Once I have my formula written down, remember, I am just multiplying everything that's not pi. A lot of us are forgetting about this 1/3. When I kind of started going through homework from this last week, we have forgotten about this 1/3 that is out in front. Sometimes we'll just do like 3 squared times 4. Okay, don't forget about him out front. And 1/3 times 3 squared times 4 is 12. So once we have our cone, now we'll do our cylinder. Okay, volume of a cylinder. Well, this one has 2 circles. There's no point, so there's no 1/3. Oh, and then pi r squared, because it is circles, and then times height. All right, so volume equals pi r squared times height. So then we want to find our radius, and our radius is, right, the same thing, right? It's still that 3 because these are sitting right on top of each other. And then our height, right, for this one is different from our height above, right? This one has a height of 8.5. So again, I type everything but my pi into the calculator. So I'm just typing in 3 squared times 8.5. And that is 76.5 pi meters cubed. So we have our 2 separate volumes. Now I need to know how to combine them. Again, we can combine by either adding or by subtracting. Okay. So you have to think about what we're doing here. And if I look at these 2 shapes, the thing I see is that these shapes are stacked on top of each other. Right? There's one shape and then the other shape is like next to it or stacked on top of it. Oh no, it's going so slow. I've been done writing. That's okay. They'll write slower. So our shapes are stacked on top of each other. So what does that tell us? When they're on top of each other, right? They're like almost like 2 separate things that you can see. Then you are adding them. So to find the total of this, I'm going to add my 2 answers. So I'm going to take my 12 pi I'm going to add it with my 76.5. Okay. Now, when I'm adding these, again, we have to be careful with these pi's. Okay, we don't type pi in our calculator, but we can't always add them or subtract them. So here, what I noticed is this has a pi and this has a pi. So these are like terms. Because they both have that pi. So I do get to add them together. Okay, so I can only add them if they're like terms, or combine them if they're like terms. And what I'm going to type in my calculator is this 12 plus 76.5. I still don't type pi into my calculator. And that equals, well, 12 plus 76.5 is 88.5. We still have pi. And our unit was meters cubed. Oh. That's much nicer. So we get 88.5 meters cubed. Okay, let's look at example 2. This one's a little bit more complicated. But again, we're going to start by looking for our different shapes. The first shape I see right the stylus. Sorry. Probably needs to restart. It's been a lot today. The first shape that I see is this one here. Okay. And while it's slanted, right, thinking about our Cavalari's principle, if we remember that big word, right, that even when they're slanted, it doesn't matter, right? This is like a rectangle connected to another rectangle. So this is a prism. And so our first shape there is a prism. Then looking for our second shape, the other thing I see is we have these circles. And there are lines here connecting those circles. Okay, so again, when you have two circles and you connect them, I'll spell cylinder for a second. Cylinder. Right, that is a cylinder. So the best thing I have like for a shape like this is think about like a bead, right? You have like some prism or like rectangle shaped bead, and there's like a hole in the middle of it for you like to put the string through. That's what that cylinder is. It's just like a hole straight through the middle of your prism. Okay, so again, we're going to start by finding our volumes separately. So, volume formula for a prism, well, it's a rectangle connected to another rectangle. There's no point, so there's no 1/3, right? On a rectangle is length times width, and then times our height. So our length for this, right, our length will come from here, that's 25. Our width will come from here. That's 30. And our height is going to be this up and down portion. Okay, and that's 25. There's no pi or anything else I have to worry about. So I'm just typing this whole thing in my calculator and I get 18,750. Keep forgetting that these need units. Let's pretend these are inches. Okay, so that'll be inches cubed. our cylinder that's in there. Remember, a cylinder, again, it's a circle here and a circle there. There's no point that it goes to, so there's no 1/3. And then since it's a circle, we use pi r squared times height. Kind of ways of remembering these formulas. Pi is not a variable. Our radius, again, thinking back to our definition of radius. Remember, the definition of radius is half the distance across the circle. If we look at where this 8 inches is pointing to this line right here, that line is going all of the way across my circle. So this is not my radius. If we remember, the word for going all the way across the circle is diameter. Okay, so this 8 inches is my diameter. So in order to get my radius and what I actually want to plug in, I need to do 8 times 1/2 equals 4. Okay, and this 4 is the radius that I'm going to use. Now our height here is also tricky. Let's go back to our volume notes from when we learned about this, right? Remember, the height of a cylinder is always the piece that like connects the two circles. Here we had our circle on top and our circle on bottom, and we were connecting them. Here we have our circle on the left and our circle on the right, and we were connecting them. Okay. So if we look here, we have our circle over here and our circle over here. And again, my height is going to be that distance that connects them. Okay, so that's the number I'm looking for the height of this cylinder. Now there's no number actually written there, but a lot of times again, these are dimensions, right? Height is just one of our dimensions. Radius is a dimension, length, width, those are all dimensions. Our dimensions are sometimes hidden within the bigger picture, okay? So if I'm going from this far left side to that far right side, it shouldn't matter how I get there. Whether I get there on the edge here or through the middle here. So this is the same distance as that 30 inches. Again, because they're both going from like the front face of your shape to the back face of your shape. So that distance will be the same no matter which line you choose to take. This does have a pi in it, so I'm just typing in 4 squared times 30 into my calculator. And 4 squared times 30 is 480. And we don't want to forget about our pi. So now that we have our two separate volumes, we have our volume of our prism and the volume of our cylinder, I want to know how I'm going to combine these. Okay, again, we have adding or subtracting are both possible ways. So in our top one we added, right? There was one on top of the other. If you look here, our cylinder is inside our prism. So the cylinder is a hole inside the prism. So it's a hole and it's inside. When it's inside and it's a hole, right, you really took that volume away. Right? I started with this bead, I drilled a hole straight through the middle of it, and so I removed a piece of it. So if I'm removing something, then I'd be subtracting. So anytime it's like inside the other shape, you're going to do subtraction. So our total is I'm going to take my two shapes and subtract them. So I have 18,750 minus 480 pi. Now, the most common mistake here is that we subtract 18,750 minus 480 in our calculator. But we have to be very careful. This one has a pi, and there is no pi in our prism, right? So these are not like terms. Because of that pi. I don't know what this I is doing. Not like terms, because there's that pi. So that means, when I say what this is equal to, I just write it exactly how it looks. And add in a unit. So we get 18,750 minus 400, what happened there? 80 inches